So good morning. Good morning, everybody. Yesterday morning, before the conference, I was sitting at breakfast together with this person over there, Graham. And Graham asked me, what should we expect from this conference? And then I said, you better expect nothing. But this gives me the opportunity, Dean, to thank you for all these some things that we've heard so far. It's a great treat, I think, for everybody here in this room. So thank you, Dean and Dean's Dean. For doing this for us and for yourself, of course. So what I want to do today is I want to give you a brief introduction into a kind of thinking about mental processes, which actually doesn't come from psychology or cognitive science, but it comes from the theory of dynamical systems. And a key notion in the theory of dynamical systems is the notion of stability, and this implies instability as well. And that these two notions, stability and instability, and intermediate notions like marginal stability, play a significant role for a distinction between two types of what I call nothingness. And the two types are nothingness type 1 and nothingness type 2. And I want to start this this talk with some words from a very influential and still very important psychologist and philosopher. That's William James. We heard from William James yesterday already, and this gives William James a little bit of a different twist. And here is the quote. So I need glasses, you know. When the rate of change of a subjective state is slow, we are aware of the object of our thought in a comparatively restful and stable way, stability. When rapid, we are aware of a passage, a relation, a transition from it or between it and something else. Now then he suggests some terminology. Let us call the resting places the substantive parts and the places of flight the transitive parts of the stream of thought. It then appears that the main end of our thinking is at all times the attainment of some other substantive part than the one from which we have just been dislodged. And we may say that the main use of the transitive parts is to lead us from one substantive conclusion to another. We may say. Now it is very difficult, introspectively, to see the transitive parts for what they really are. If they are but flights to a conclusion, stopping them to look at them before the conclusion is reached is really annihilating them. Whilst if we wait till the conclusion be reached, it so exceeds them in vigor and stability that it quite eclipses and swallows them up in its glare. Let anyone try to cut the thought across in the middle and get a look at its section, and he will see how difficult the introspective observation of the transitive tracts is. The results of this introspective difficulty are baleful. If to hold fast and observe the transitive parts of thought's stream be so hard, then the great blunder to which all schools are liable must be the failure to register them and the undue emphasizing of the more substantive parts of the stream. I think this is very clear. It's a research program, actually. Look at the transitive parts. That's what I have in mind now. So the theory of dynamic systems has become interesting for cognitive scientists, also for neuroscientists, since the 1980s. And two key names here are Walter Freeman, who you all know, and a less well-known person in Greece, John Nicholas. And they did made the first attempts to really translate key notions of dynamic systems theory to perception, cognition, and the like. So they suggested to study aspects of perceptive and cognitive processes by describing the nonlinear dynamics of the state X. X will always be a state of the mental system in a suitable state space. So you have a suitable state space here. This is the two-dimensional state space for the system. It's a cartoon, of course, right? It doesn't say anything special. It's just giving you the idea of the framework of the whole thing. And here you see something that you may or may not know. This is an ordinary differential equation of first order. This is the temporal derivative of the state of the system times t. And this is a nonlinear matrix of coefficients which couple all the variables of the system. It can be 2, can be 4, can be many, many more. So x, these are the variables. This is a vector which has n components. So these are the n variables of the system, also called observables. N is the dimension of the state space. So in this case, it will be 2. F is the nonlinear coupling between the different variables. Nonlinear means there are squares, there are maybe logarithms, there may be, I don't know, exponentials, whatever. It's not linear. R is an external control parameter, and T stands for time. Nonlinear dynamic systems evolve as a function of time. Now the idea is this. In nonlinear dynamic systems, you always study how an initial condition moves in this state space until it reaches an attractor, and there it stays for a while. So now what Freeman, Nicholas, and others suggested was to consider the mapping of an initial condition onto an attractor as a mapping of a stimulus, now for the mental system, a stimulus onto a representation in your mental space. Right? That's the key idea. It's very easy to understand. And then what I want to do now is to analyze the stability properties of this mapping in an attractor landscape, which is represented by a generalized potential V. And you will see on the next slide what that means. So here's a brief definition of a number of stability properties. The state X is stable if the curvature of the potential around that state is positive or 0. Then you have two different distinctions between this stability definition. A state is called marginally stable if the curvature is 0, so it's just a flat potential. And it's asymptotically stable if the curvature is really greater than 0. And you will see immediately what that means pictorially. A state is unstable if the curvature is smaller than 0 around it. So this is how it looks like. Again, this is a cartoon. Here the state space is only one-dimensional, so it's as simple as it can get, right? So what you see here is, here you have a flat potential, right? So there's no curvature, there's not even a slope. It's just everything is 0. So whenever and the ball here, that's the state of the system. When you perturb the ball, it just goes somewhere and then it stays there. So there's no real force on the ball.
Does that mean you're talking about mental states?
Yes.
There. The mental state is invariant, or it can't change. There's something, a restriction on its...
It can only change due to external perturbations.
Yes, right. Yeah.
So this is the marginally stable state. This is this one, right? Now here we have the asymptotically stable state. That would be at 1b. Here we have a potential that is not flat. It's a curve. It's a valley, if you want. So if you put the state here, if you take the state here and elongate it away from this minimum, then it will return to the minimum. And this is what asymptotic stability means. When you perturb the state, it will always go back to the state from which it comes. Right? So this would be an asymptotically stable state. Now this situation is particularly interesting because here you have two situations in which you can have stable states. It's called a double well potential, or double minimum potential. Double minimum means there is a maximum in between, which separates the two states. Now remember the quote from William James, these would be substantive states, this would be the transitive state. When you go from here to here, you have to do this via this transitive state, and the transitive state is unstable. That's the reason why these states are so hard to observe. They are unstable, they decay immediately into this or that. So there's this guy, John Gebser, I don't know whether you have heard of him, a Swiss philosopher. He came up with an interesting categorization here, or interesting distinction between these three different situations. This is what he calls a categorial state. It's a state that activates an existing category or an existing representation. This is a non-categorial situation. There is no category here, simply. There's no representation. The potential is flat. There's nothing where the state can really go into and stay there in an asymptotically stable way. And this state, this one up here, this is what he calls neither categorial nor non-categorial, and he calls that acategorial. So A in the sense of neither nor. And I give you a little quote here, just to make clear what I mean. This is from Gebser's main opus that was published in 1950 something. So he says, each categorical system is an ordering scheme by which real appearances are fixed and objectified. In this sense, it is a static and spatial framework. Categorical systems are sufficient for an understanding of the world only within a non-dynamic conception of the world and corresponding notions. For this reason, it will be necessary to accept acategorial elements as well, in the moment in which we succeed in perceiving acategorial effects as such, and not as categorical fixations, the world becomes, he says, transparent. So, what William James already asks us for, Gebser would call, we have to take into account acategorial states in our mental system, the transition states, the transitive states. Now, you see here we distinguish two essential objects in this whole picture. We distinguish potentials and states. So potentials standing for representations, and the state, depending on where the state is, the potential or the representation is activated or not. When the state is at the bottom of the potential, in the bottom of the representation, so to speak, then this means that exactly this representation is activated and we experience it. Same here. If the state is here, this representation is activated and this is not activated. If the state is here, this is activated and this is not activated. So if this is the flower and this is the glass, then we can switch between activating the representation of the flower, then we experience a flower. If we activate the representation of the glass, then we experience a glass, hopefully a full one. So, since we deal with representations in terms of potentials and states, we can now consider the dynamics of these two objects separate from one another. So we have a state dynamics, which is usually fast. That's the dynamics that William James was discussing in the quote I gave you. So for instance, we can have the state at a minimum, at a potential minimum. Now I have to refresh your memory with this. So that was the situation like this. So the state x at a minimum would be here. and then we move it to a maximum. So we move it up here. And then it could possibly, that's in the brackets, it could possibly go down to this state right here. So the state X moves out of a stable category or representation, which is maintained but not actualized into this one. So in order to do this difference of the potential must be expanded, otherwise it doesn't get up here. So something must happen to push the state out of this minimum to this maximum. In physics, it's clear what this is. It would be just energy. You put the energy in the system, and then this pushes the state out of there. In psychology, it's difficult. It's difficult to talk about energy because there's no really good definition of energy in psychology. So this is the dynamics of the states. But we can also have the dynamics of potentials, of representations, right? Whenever we learn something, we learn a new representation, a new category. So this changes the whole landscape of potentials. There's a new category coming up, and this usually has an effect on the others in the neighborhood, of course. So for instance, we can change the potential from a concave one, which would be one which looks like a valley, and to make it flat, right? If that happens, then we reduce the stability of a state in that potential, and the difference of the potential between minimum and neighboring maximum is diminished, or vanishes even, and this means that we dissolve categories. For instance, this happens impairment-induced, it can also happen drug-induced. There are many possibilities to do that. Can also be done by meditative techniques, and I will come to those examples later on. The other option would be we have a flat potential and deform it into a concave potential. Then this is something like a formation of categories where there were no categories before, and this would be the emergence of new cognitive contents. I mentioned before the example of learning. Learning is a typical example where new categories arise. Now, so we have three different situations. We have categorical mental states, and when the state of a system is in a representation, then we experience something. Namely, we experience the content of that representation. It's sometimes called a conceptual content, sometimes it's called an intentional content. Anyway, we experience the content of that representation in which the state resides. Now we have non-categorical states, and this I call the experience of nothing type 1, because these non-categorical mental states are not in a category, and there are no categories even in the neighborhood. So it's non-categorical, it's an experience of nothing in the absence of something. There's nothing in the environment. Acategorical mental states are these guys here. Allow us to experience nothing type 2, namely the experience of nothing in the presence of something, because these two representations are closely related to this instability. So there is a potential difference between that state and those. So around this instability, around this acategorical state, there are representations, they are just not activated, because the state is here and not there. So there's a crucial difference between these two types of experience, because experience type 1, that would be an experience of just a flat potential. There's nothing in the neighborhood. There are no categories, no representations around. And the experience of type 2 would be something like this. This is marginally stable. This is truly unstable. It's also another difference. So now from a formal point of view, the talk is finished now. And the rest is phenomenology. So what I want to do now is just give you an idea of how I understand phenomenologically these two different types of nothingness. And of course, I hope that you can correct me whenever something is completely wrong, or when you think about it in other ways, and so on and so on. So nothingness type 1. That's the idea that given you are in your ordinary everyday environment with all your representations, in some way you manage to dissolve or deactivate representations. So you make your potential flat. And this is a situation, I list now a number of terms which have been proposed by different people, which I think all describe this situation. Minimal conscious experience, that's Thomas Metzinger, and this was mentioned yesterday already. Various meditative practices, you went through those, I think. I'm just listing one of them here, non-dual awareness. Then a very interesting approach by Deleuze. I don't know whether you like Deleuze or whether you like French philosophy at all. I'm not sure about that. But Deleuze, in this respect, Deleuze is very interesting, I can tell you. Because Deleuze really makes a point that, and describes in detail how these non-categorical states, these nothingnesses of type 1, can be understood. And he sees the real difficulty in this, how to do this. That's why he coined the notion of immanence as the vertigo of philosophy. It puts you into a state of vertigo if you go into these states. That's what Deleuze says. And Christian Kerslake has written a very good book about that, which is much easier to understand than Deleuze himself, sorry to say. Then in Carl Jung, we have the notion of the mysterium conjunctionis. This was his final opus, in which he talks about the experience of the ineffable in 3 different steps. There are mysteriums of the first kind, of the second kind, and the third kind. And the third kind is the most comprehensive one, leading, in his way of thinking, leading us to the experience of an undistinguished and how can I say, an undifferentiated reality as a whole, the so-called unus mundus. And we also have earlier notions that lead us into the same direction. The highest form of knowledge that Spinoza knows is scientia intuitiva, leads us there too. Nicholas of Cusa, coincidentia oppositorum. So when all opposites coincide, then there's no distinction anymore between them, and then we have a flat potential. Or the Unio Mystica, Plotinus, and when we go into this Neoplatonic, Platonic, and the history of Neoplatonic ideas, then of course we find many, many more. I discovered this book by Shinichi Hisamatsu, was mentioned yesterday. James, you mentioned it in some of the discussions, I think. He has a book which has I don't know the English, I don't even know whether it's translated into English. It's translated into German, and when you translate the German title into English, it would be this, The Plenitude of Nothingness. And he lists a number of properties of what I call nothingness type 1 in this book. It's 8 or 9 properties. And I just wanted to show them to you because this is now really from another cultural context, right? So the first property is that these states are unrestricted by any inner or outer appearances, and Hisamatsu relates that to his notion of freedom. They're omnipresent, which means they're independent of space and time. There is no space and time. They're infinite, spatially and temporally unbounded. They're distinction-free, so there are no distinctions at all. And I'm just giving you 3 examples here: sacred versus profane, good versus evil, true versus false, and whatever you can think of, it doesn't exist in these states. Because if there were distinctions, then the state would be not non-categorical, right? So the fifth criterion would be purity, void of mental or material or other attributes, permanent, no becoming, no elapsing, no movement, purpose-free, no goals, no ambitions, no telos, and nothing, neither being nor non-being. We talked about Hisamatsu yesterday night real quickly, and James told me that he is not really a representative of the Kyoto school, but he was teaching in Kyoto quite a while, nevertheless. So he's probably, he must have been influenced by the Kyoto school, even if he's not one of the main representatives. Now, to finish this nothingness of type 1, I also want to talk about the idea of no self real quick. I call it no ego, just to make clear that there are traditions in which self means something different from ego. For instance, the Jungian tradition. So I call this no ego, and this is a classic anecdote where the monk asks the pupil, where is the Tao? Directly before us. The monk, why don't I see it? Kwan, you cannot see it because of your egotism. If I cannot see it because of my egotism, is your reference able to see it? As long as there is an I and a you, this makes the situation difficult, and no Tao can be seen. Can it be seen when there is neither I nor you? When there is neither I nor you, who should be able to see it here? So this relates to the question you posed. If it's not someone who can see it, maybe there is a somewhat that can see it, right? And in this situation, right here, the flat potential, there is no single representation available. Also not the representation of the ego. So the ego would be activated if you would be here or here, then this could be an ego situation. Here there is no ego, but nevertheless there's a mental state. So this is a partial answer to your question. This is not, of course there is no who, or no person or something like that who can experience this, but there is a mental state nevertheless, which answers the question to the what. Not to the who, but to the what. So, anyway, this is very briefly and superficially a set of ideas how these nothingnesses of type 1 might, I don't know, look like. Now I come to nothingness of type 2, and of course this is the nothingness of these states. Nothingness, this is nothingness in the absence of something, this is nothingness in the presence of something. Some things might be these things here. And I think one very nice example is bistable perception. A phenomenon that has been studied for 150 years in psychology and cognitive science, long time, and I show you here a figure which is called the Necker cube. It's a three-dimensional object projected onto two dimensions. And when you look at it, you see the phenomenon best when you look at the middle of it, not onto one of the edges, like in the middle of it. Then wait a few seconds and you see something, probably. Most of you, I guess. It switches. In the beginning you see it as if you look at it from above. Typically you see it from above in the beginning. There's a bias in the representation. And after a while, 3 seconds, 5 seconds, 7 seconds, it switches and you look at it as if you look at it from below. And this is spontaneous, right? You don't have to do anything, it happens simply. So these are the two representations between which it flips back and forth. And now, when you look at this picture here, you see immediately how that maps into the theory. Because you start with the representation of the cube from below, or from above, let me say. Then you see it from below, then you see it from above, see it from below, and so on and so on. You never see this state. I mean, maybe some of you will, but most of you will not see this state. That's the state that William James reminds us is a big hole in our whole thinking, the transitive state. So, bistable perception, as I said, has been an object of study for many, many years. And there are many models to study it. And each model describes particular features, but not others. And even different models are wrong on certain features. And so at some point, 15 years ago, together with two collaborators, Thomas Filk and Jürgen Kornmeier, we started a completely new approach to model this. And that's called the Necker-Zeno model. Necker because of the Necker cube, and Zeno because the model that we have has some kind of Zeno-like effects. I will tell you immediately what that means. So the Necker-Zeno model describes bistable perception, this process of going hence and forth, by two kinds of dynamics which do not commute with one another. So it depends on the sequence in which you apply these dynamics, what the result is. The Zeno-type effect is that you can stabilize the representations which are actually unstable, flip back into the other, you can stabilize them, and this stabilization effect happens due to observing those two states, the stable states.
Can I just ask a quick question while it's sort of still fresh? So the Penrose triangle example, which is almost like a version of that, what you get in the Escher pictures. I'm trying to see whether it would fit on something like that, or type 1 or type 2, because you can't stabilize it into any representation, so there is nothing for it to go to, but it's also not nothingness. It's something very weird from this point.
So the Necker cube is an ambiguous figure. Mm-hmm. The Penrose stuff is paradoxical, is an impossible figure. And I will come to that in a later section. Okay. But there's really a difference between, in the Necker cube, an ambiguous figure, you get the switches which are spontaneous. In the paradoxical figures, in the impossible figures, you can never settle on one of those. You're always pushed back. But that will be coming.
Could I just ask a question on the Necker cube?
Yeah.
Where seeing it as a tiling pattern, just a two-dimensional tiling pattern.
Tiling
pattern.
Yeah.
Just seeing it as if you were going to tile the floor, you'd have to work out what tiles to tile.
Yeah.
Where does that fit in at all to it? I mean, does that have a place in this? Because that seems to be a thing you can do. It's not spontaneous. You'd have to sort of learn to do it. You've got to sort of think of it as if you were looking at tiles on the floor or something like that.
So every subject, I mean, in psychological experiments, we talk about subjects. Has different variations of what they see.
Right.
When you talk about the tiling, then what you do is actually you do not reconstruct the three-dimensional origin of the picture, but see what you see still in two dimensions. Mm-hmm. And that's, of course, that's possible. And then you will not see the dynamic, of course.
No.
Exactly. Yeah. So you should try to reconstruct the three-dimensional figure, which is, of course, projected onto two dimensions, and then only when you reconstruct the three-dimensional figure, then you see the flip-flop. I don't know whether you can do that, but you should try.
It seems to me it's harder to see it as tiles than the two ones you know naturally see.
Okay, yeah. I mean, you can see this as many things, but I think the naive observer, maybe you are spoiled because you saw it too often, I don't know. But the naive observer will see it just in terms of, this kind of dynamics going back and forth.
Yeah.
And when we do the experiments with subjects, of course, if some subject has been used in an experiment, it's spoiled for any future experiment because they've seen it too often. Right? So we always have to bring in new participants into the experiments. So the Zeno effect that we model here does the following. Usually let's assume the reversal rate is 1 per 10 seconds, then the Zeno effect in the model that we apply takes care that the reversal rate becomes smaller, so the dwell times become longer. Which means that the state, but this state is a kind of metastable state. After a certain while, it goes over here. It becomes stabilized by the observation. Right? So it takes maybe 12 or maybe 14 seconds or something like that. And we can show all this experimentally. So these transitory acategorial states on the maximum can be considered analogous to quantum superposition states holding the potential for different actualizations. And so in this kind of quantum metaphor, we can also show that the lifetime of the acategorial states, the lifetime of these states here, which is very short, it's maybe 10 milliseconds, 20 milliseconds, indicates an extended duration of nowness. Nowness considered as the, let's say, the boundary between past and future, right? In physics, the extension of this nowness is always 0. That's how we conceive, physical processes. But in experience, when we experience the present moment, it's never 0. And many philosophers have written about that. Husserl, Bergson, Whitehead, and others. So there's a very interesting property of these acategorial states. They offer the potential to study the experience of an extended duration of nowness. And that's what we call temporal non-locality. Now I don't want to go through all the math here that the model contains. I just do that very quickly. I show you here one graph which is supposed to give you an idea how non-trivial and how comprehensive the Necker-Zeno model that we have developed describes experimental features. So this graph shows you some phenomena in discontinuous presentation. So you don't show the Necker cube just continuously, but you break it up. Then there's an interstimulus interval. Then you show it again, and there's the interstimulus interval again, and so on and so on. So this is the interstimulus interval in seconds, and this is the dwell time in seconds. So what you see is we have a minimum of the dwell time at around 300 milliseconds, which the model predicts. We have a quadratic increase of the dwell times when the interstimulus interval becomes longer. That's what the model predicts. It predicts the quadratic increase, not just an increase. And it also predicts that the dwell times come up again for smaller interstimulus intervals. So several really non-trivial results, which are all fitted by the model.
So what's the y-axis once again?
The vertical axis?
Yes.
These are the dwell times, the inverse reversal rates. So what the model also predicts is this kind of temporal non-locality, right? I cannot show you that in detail. I just go through these things here very quick. But this quote I want to show you, you know this person, Robert Musil. He's known for an unfinished novel, The Man Without Qualities. This is from another novel, Verwirrungen des Zöglings Törles. I don't know. How would you translate that, Jennifer? The confusions of Törles, the adolescent, maybe? Something like that. Well, let's go through the quote. We live from one thought to another. For our thoughts and affects do not flow quietly as a stream, but they occur to us. They fall into us like stones. If you observe yourself accurately, so he says, you can do something here. William James said it's difficult. He says you can do it. If you observe yourself accurately, you feel that the soul does not change its colors gradually, but thoughts jump out of it like numbers out of a black hole. Now you have a thought or an affect, and suddenly another one stands there, as if it just jumped out of nothing. If you are attentive, you can even sense the instant between two thoughts in which everything is black, he says. This instant, once recognized, is nothing else than death for us. So he really has a kind of intimate relationship, seems, to these states, and these states are just these acategorical states. Black. This is nothingness type 2. Now I come to what you said, Dean. And I call this paradox, the idea of paradox. In paradoxical situations, you don't have ambiguity, you have contradiction. Right? So in paradoxical situations, you also have maybe two different possibilities in which you can see an object, but they are, once you go into one of them, you're immediately pushed back because you see globally this is inconsistent. I will show you an example in a second. And if you want to relax in this state, you immediately see it's globally inconsistent, you're pushed back. So you're pushed back from both sides. And for a long time we thought, in our group, that this might be a very interesting approach to really stabilize the unstable state, because you're always pushed back from the stable states. So far we were not successful with this, but it's still an idea. You all know this, I guess? And here, so you see this direction goes there, this direction goes there, and here you see the Joker sitting in the shadow, and the Joker has an object in his hands. That's not the Necker cube, that's a paradoxical cube. No. In the paradoxical cube, you may not see it very well from behind. This corner and this corner both point into the same direction, which is impossible. I mean, you can paint it, but you cannot make such a cube. So this is the paradoxical cube, which exactly does what I just mentioned to you. It always pushes you back into the unstable state in between. You can never relax in the state here or here. So, Roger Penrose, one of the Nobel Prize winners 3 or 4 years ago for his work on black holes, not the black holes of Robert Musil, the real black holes. He suggested to model these impossible figures in terms of a certain mathematical approach, cohomology theory. I don't describe that in detail. And going back to, Graham, to your talk yesterday, this is another interesting idea to really use paraconsistent logic for true contradictions like this. This has not been done so far for paradoxical figures. So that might be a very interesting new idea here. And in Zen practice, we know that certain, all these short sentences, short statements, which are known as koans, they're all paradoxical, and they have the goal to bring the adept, let me say, into situations where he can never relax into one or the other stable state, just keeping him in this intermediate part. And the goal, of course, is, in my terminology, to let the adept experience nothingness of type 2. So how much time then? Maybe 3-4 minutes? Now I come back to the no ego idea here. And the ego, of course, is one of our most stable and one of our most established categories. I mean, without the stability of the ego category, we wouldn't have anything like identity of ourselves over time. But alterations of first-person experiences are to be expected in this picture if either the stability of the category changes or if the mental state leaves that category. These are always the two possibilities. You can have a dynamic of the potential or a dynamic of the state. But you can only talk about this in this way if you really make the distinction between states and potentials in the first place. Otherwise, and this is when you look into the literature, in much of philosophy of mind, representations and states are just treated as if they're the same. This is nonsense, I think. You really have to distinguish them. So the first option is the stability of the category of the first person singular changes. This is usually described by psychopathological impairments, where you have a reduced stability of the category of the first person singular, and this implies a regressive or even a lost sense of ego. There's literature about that. This really happens. Or what also can happen is that the category of the first person singular disintegrates, and the phenomenology of this would be a kind of disintegration into partial egos or multiple egos. So this would be the dynamic of the potential. The dynamic of the state looks very different. I mean, the dynamic of the potential would simply be that you flatten the category of the first person singular and make it flat. In the dynamic of the state, the situation is different. This would be, again, nothingness of type 2. You can try to move your mental state out of the category of the first person singular. And this is, of course, extremely difficult because it's so stable and it's so omnipresent almost, right? If you find ways to move your state out of this deeply stable category of the first person singular, then you can reach something that, again, Jean Gebser calls ego freedom rather than loss of ego. I'll show you another quote here. He says, again in this book, The Ever-Present Origin, only the overcoming of the I, the concomitant overcoming of egolessness would be flat potential. And egotism places us in the sphere of ego freedom. Ego freedom means freedom from the I. It is not a loss or a denial of the I, not an ego-side, he says, but an overcoming of ego, of, one might say, of the dominance of the ego. Ego consciousness was the characteristic of the mental consciousness structure. Freedom from the I is the characteristic of the integral consciousness structure. That's a structure of consciousness that Gebser was talking about in a lot of books and papers. So, in order to do that, in order to move your mental state out of this category of the ego, which overshadows everything essentially, a lot of energy must be expended, a lot of potential. And you may or may not know this very influential book by Thomas Metzinger. He published in 2003, Being No One. So, a friend of mine, Scott Jordan, who also plays in a rock band, he made a song, actually, about Thomas Metzinger. And the name of the song is It's Hard Work Being No One. And you can find that song, it's very nice. It's very funny and nice. You can find it on YouTube. So then there is, of course, another kind of change of the category of the first person singular, transformative changes of how you experience who you are. That happens. I mean, we were talking about mystical experiences yesterday. This is one possibility in which that can happen, and in many cultural contexts, we have this notion of rites of passage, or you could say even in Western contexts, when adolescents go through this age of 14, 15, 16, maybe even earlier, for some also later. This is also kind of rite of passage. So the way in which people experience their own I can change. So now this is the next to final slide here. This is a quote from Søren Kierkegaard in the concept of anxiety, which I find overwhelmingly deep and dense and everything. This is a description, I think, what Kierkegaard describes in this brief quote is the transition from here to here and then to here. Now, listen to it. One can compare anxiety with some kind of vertigo, again the vertigo thing. He who must look down into a deep abyss will feel vertiginous. But what is the reason for this? It is both his eye and the abyss, because what would he had, what would be had he not looked down, I'm sorry. What would be had he not looked down? In this sense, anxiety is that vertigo of freedom which occurs if the spirit is about to set the synthesis. Freedom now looks down into its own possibility and then seizes finiteness in order to stick to it. In this vertigo, freedom collapses. So this is the on the way up here, this is where the anxiety happens. This is the state of freedom in this quote. That's my interpretation. Here, freedom collapses and seizes finiteness. And then he says something which is typical for Kierkegaard, of course. In this instant, everything is changed, and when freedom rises again, it recognizes that it is guilty. Kierkegaard's writings are full of guilt and sin. So guilt occurs everywhere in sin. I could also say it recognizes that it has lost a little piece of innocence. I don't know. Between these two moments lies the leap, which science neither has explained nor will be able to explain. I can only recommend really to meditate on this quotation. I think it's wonderful. Chris, what do you say? This is the last slide. This is a summary. It's it's again a slide from a very nice work of Bert Brecht, a German writer, and it's about Turandot. Turandot we know from Puccini's opera, but this is Bert Brecht's way to talk about it, The Ice Princess. The teacher says, "See Fu, what are the ultimate questions of philosophy? See Fu, are the things outside of us, for themselves, without us, or are they within us, for ourselves, not without us?" The teacher, which answer is the right one? See Fu, no decision has been found yet. The teacher, to which answer does the majority of our philosophers tend? See Fu, things are outside us, for themselves, without us. Mind-independent reality. The teacher, why did the question remain unresolved? See Fu, the Congress that was supposed to bring the solution took place, as for the last 200 years, at the monastery of Mizang, close to the Yellow River. The question was, does the Yellow River really exist, or does it only exist in the minds? During the Congress, much snow melted in the mountains. The Yellow River rose over its banks and flushed away the monastery with all the conference participants. So the proof that the things are outside us, for themselves, without us, could not be achieved. Well, the lesson is finished. Yeah. I'm finished too. Thank you very much.
Harald, fascinating, thanks. So this idea that inconsistent images like the Penrose triangle and the Escher staircase and so on are bistable. I wonder, is there actually empirical support for this, or is this sort of based on an assumption that we can't possibly have a stable representation of an inconsistent state of affairs?
Yeah, I wouldn't call them bistable, at least not in the same sense as ambiguous figures. But I would say, I think the comparison between the Necker cube and the paradoxical cube is interesting, because then you can really see what the differences are. In the Necker cube, you really have the ambiguity which expresses itself in the spontaneous switch. In the paradoxical cube, nothing switches, and the interpretation that I tried to suggest was that whenever you want to go into one of the two states, you're pushed back because you see that this would become globally inconsistent.
So I guess what I'm questioning there is the idea that we have this need to go into a consistent state, and there are two consistent states and we're trying to go into one of them. I'm just raising the possibility that there's an inconsistent state and we just go into that and stay there.
Yeah. I mean, this would be, this was our hope when I said that when we study this phenomenon, just with participants who are always pushed back from both metastable configurations, then we could push them into this actually unstable state and stabilize it, so they would experience the inconsistent state. That's exactly the idea. But we were not successful so far.
But you saw some actual evidence behaviorally or neurophysiologically or something that they are in fact flicking back and forth between two different states?
No, what we saw when we when we made attempts to put that into an experiment with participants, what we realized was they became very uncomfortable because they realized they cannot make this in some sense consistent, and after a few attempts they would just stand up and leave the room, and they would say, "This nonsense we don't do."
All right, well that's behavioural evidence of some kind,
This
I
is
guess.
behavioral evidence. Of course, I mean, this morning we talked about this whole idea of the principle of non-contradiction, right? And this is, I agree, this is in our cultural context, it's totally non-intuitive. And then, of course, when you take that into consideration, then I can understand that, naive participants, they hate this, even emotionally. I mean, we got emotional reactions, they would say, no, we don't do this nonsense.
Yeah.
So.
Yeah, my question, by the way, is influenced by one of my old teachers, Chris Mortensen, who has been working for years on trying to model impossible images like the Escher ones and the Penrose ones using paraconsistent logic. So,
he did it, okay.
Well, I don't know if what he's actually come out with, but he's been trying to pursue that project for ages. So.
I know Roger Penrose, who I mentioned, he wrote a paper, I think in the 1970s or early 80s, in which he made really first step to address the tribar.
Oh yeah, as in the triangle.
The triangle, which he calls it the tribar. I think he actually invented it.
Yeah.
And he wanted to, and he tried to model that in terms of cohomology theory, which is quite interesting. And I don't know, nobody followed up on it, so.
Yeah, I don't know where Chris has actually gotten to. Graham might know more than I do.
Yeah, I mentioned Chris at breakfast. So he's got the book on inconsistent geometry with applications to these.
Yeah, you mentioned it this morning, yeah. Yeah, that's actually a good idea to go back to that and see what he did. So.
Yeah, I mean, I had just a follow-up on this tribar business again, whether this is a good representation for that, because...
No, for the tribar it isn't.
No, because you've got, so these are categorical representations,
Yeah.
these are like
That's right.
stable states, but the problem, it's almost like you've got a spike with this sitting up there and nothing for it to fall into.
For the tribar it doesn't work at all. For the paradoxical cube, maybe. Because for the tribar you have, in the tribar you have three pieces of the tribar just where they change direction, right? The tribar, which are inconsistent. Here in the paradoxical cube it's only two. So for the tribar you would need maybe three of these minima to model it properly.
Yeah, but it still wouldn't model it properly because they're not. Well, it would locally. These would be like little local elements of the tribar. Right?
Exactly.
Each representation would be just one segment of the tribar.
Yes.
Yeah.
Yes.
I get it.
Yes. And of course, then then your state space is not two-dimensional. It's not one-dimensional anymore. You have to add a third dimension.
Yeah.
Because you want one unstable state in between. So these two and the third one would be.
Yeah. Ruben, was it on the same point? Because Graham's just ahead.
Vaguely, but go ahead.
No, that's all right. It's on the same topic you had.
I don't know if exactly it is, but I was more focused on this from a phenomenological, meditative sort of point of view, and you mentioned Zen koans and things, and there was one quote up there that really rung untrue for me, which is that there's some sort of blackness between thoughts.
I don't insist on the black. I don't know. This is just music.
Yeah, because what meditation to impact. There's Joseph Goldstein, who's an insight meditation teacher, who presents an image very much like this as an example of what happens as meditation progresses. So initially there's a sense that there's thought, gap, thought, but over time you realize that those gaps are actually filled with your sort of embodied present experience, which is very much not nothingness, quite the opposite.
Interesting.
And what the experience is actually is that what you end up seeing is that which you were caught between thoughts was much more like a kind of nothingness, because it was this abstract thinking realm, and now you're actually in the presence of the moment and embodied, and your attention is no longer caught in these two gaps of thought to thought, and your attention instead, that what looks like a hill now drops down and becomes its own valley, which is actually now your attention has found homeostasis, stability within the embodied experience. And so that's just a phase of meditation, and koan can drop there as well, but then there's nothingness is much further kind of along the path according to most of these traditions, I would say.
No, I get that, but then even in my definition, if there is a valley, if the local maximum is replaced by a local minimum, even in my definition, this would not be nothingness anymore, because then you have content that you activate, right?
Right, because that doesn't. My intuition here is then that anytime there is a these two valleys, the hill is not really a hill anymore. It eventually stops becoming a hill if there's any attention given to the contents of, because the transitory then becomes
becomes its own representation.
Exactly.
Just on that note, because that blackness note that came from Musil in the Turles.
Yes.
And there's actually quite a bit of literature on Musil being in a half fight, half making fun of Fechner. So Gustav Fechner, this doesn't come out of nowhere. He's actually engaging with a literature that speaks to exactly that, and that tries to problematize what happens when you start to articulate introspection. We talked about this a little bit before.
Interesting.
So he's saying there that, and Fechner has all of these meditations about how this is actually a walk, and how the process of articulating what happens during the walk, that is introspection, is not straightforward. So people have been reading that bit in Musil as some kind of, not exactly reflection, but engagement with the idea that how we describe the perceived hills is far from straightforward, and in a way, because of the temporality that you quoted William James on, right? It's how do you, what Fechner was all about, the temporality of the walk seems even, but when you recall it, it doesn't come out as even, because you're going to highlight when you came past this tree, and then you're not going to give equal time in your narrative about all the time that you wandered along where there was no tree. So that's the kind of thing that Musil allegedly engages with, and that speaks to your sense that this is weird about the sudden black hole.
Interesting. Thank you.
Great.
Yeah, I had a couple of thoughts. One's about the line paradox. Maybe we can talk about that over coffee.
Yeah.
The other thought concerns this little diagram here. And I was thinking about phenomenology, and in particular my phenomenology of the switch in the Necker cube. And what it seems to me phenomenologically is that there's no transition state. There's an instantaneous switch. And what that might suggest in terms of the little diagram is this: you've depicted V as a continuous function, but another possibility, which might be more applicable to my phenomenology at least, is there's a discontinuity there, that you've got a sudden switch from one state to a different state with a point of discontinuity in between. So there's just no value of the mental state, so to speak, as represented by this mathematics.
Can I react to that right now?
Please.
Of course, we know in perception theory, in perception science, that the way in which we perceive has a temporal resolution. And when you, for instance, when you show subjects different, stimuli in a sequence, and you make the time interval between the stimuli smaller and smaller, at some point they don't see the transition anymore. It's just the time interval depends, of course, on the subjects, and there's a critical dependence on age. So when you get older, you cannot resolve more than 100 milliseconds maybe. You're still young, you can maybe 50 or 60 milliseconds. But anything below 50 milliseconds or 40 milliseconds is any process which would go on that time scale would be unavailable for our perceptive system. And I don't know, of course, I don't know how your perceptive system works, but at least that would be a possible explanation for why you see discontinuity, because you simply cannot resolve it.
Well, I don't see a discontinuity. I mean, there's just an instantaneous transition. But I was careful to say that I'm describing my phenomenology.
Yeah,
I'm not
right.
describing my mental or brain processes. And at least phenomenologically, there's this sudden switch.
Yeah, and then, okay, yeah, that's true. Yeah, I mean, many people would report exactly that.
Yeah. So if you think of the diagrams as a description of phenomenological states, then the discontinuity seems kind of appropriate.
So, as I said, this could be an effect of lacking resolution, but if it's a real discontinuity, then it would be very interesting how to model that. Right?
Well, but the model's easy. You just have a discontinuous function.
Yeah. We don't like these very much. In science, we don't like them very. Even if there is something like a discontinuity, like when you have, for instance, an atom in an excited state, and then there is radiation coming out of the atom real axis, and which is actually described as a discontinuous state. People always, the whole history of quantum mechanics is full with attempts to describe that in a continuous way, right? Which failed so far in that sense.
Jim, is it a quick question, Jim?
Yes, I think.
Okay.
I presume you can answer. It's an obvious question, so you should be able to answer it quickly.
Then please put the question as a yes/no question.
Okay, yes or no. Why can't you use the physics or changes from one state to another with an instability in between, for example, crystallization, or things that happen in metallurgy, or even the boiling of water? There's a transitional moment there, right?
Yeah.
And as you said, there's no zero. The nowness is always a zero in physics. They don't count for that last.
It's not extended. Yes. Yeah.
So
that's right.
type 1 would be impossible. Obviously,
Yes.
that would be creation from nothingness.
Yes.
Okay, but so it's already type 2. Why can't you take that as a model for what goes on in the brain and just say, well, we haven't got all the variables?
Yeah, I have an answer to that actually. So in physics, you're talking about phase transitions.
Yes.
Phase transitions are instantaneous in the limit of n toward infinity. So infinitely many particles, right? In reality, physics is always finite. So when you really want to model a phase transition realistically, rather than in the limit, then you always have a time that it takes to go through the transition, and that, when you model that, then you are still in the domain of continuous developments, continuous evolution.
But why doesn't that work for the model?
No, that's what I'm trying to suggest, actually. I'm trying to suggest that this is not a phase transition in the limit n toward infinity, but I try to suggest this is a phase transition for, in the analogy, finitely many particles, and then it takes time.
All right. Thanks, Harald.